This video is about using the z-table in reverse. So for example, if I wanted to know what z-score corresponds with the 60th percentile. A percentile indicates that the percent of the population that has a value less than that value. Doctors use it a lot when they're talking about newborn babies. So a newborn baby having a weight in the 60th percentile means that roughly 60% of all newborn babies weigh less than that baby. So that's the percent less than. So what I do is I look at my z-table inside the actual table, so where the proportions are, and I'm going to find one that is really close to 60% or 0.6000. I'm going to find as close as I can get to that. So if I look at my z-table and find really close to 0.6000, I'm going to get pretty close but not exact. So I have one right here that's 0.5987 and then another one right there that's 0.6026. They're both pretty close. Actual closest one is 0.5987. But either one of those would really work. And what we're doing now is we're writing the z-score that corresponds with that particular proportion that's really close to 0.6. So that z-score would be 0.25. If I wanted the 10th percentile, I would come over here to this side of the graph and find 0.1000, as close as I can get to it. We can get really close to it right there. It's 0.1003. That's pretty close. So that z-score would then again be negative 1.28. So that is how I find a z-score from a percentile or from a percent. So the type of problem that I would use that on is one like this. Approximately what weight represents the cutoff for the bottom 20% of adult female walrus weight? I'm going to draw a quick normal model so we can kind of visualize what that means. Again, we have this mean of 812 right in the middle, and we want to know what is the cutoff for the bottom 20%. So basically that means if I drew a line right here and shaded below it, I want that shaded region to be 20%, and what I want to know is what weight would give me that bottom 20%. So the first part of this is finding a z-score from my z-table. So I have a proportion. Bottom 20% is just another way of asking what is the 20th percentile number, and find that 0.2 like I showed you before. So I'm going to look in here somewhere and I'm going to find 0.2000 as close as I can get to it. I get pretty close right here with 0.2005, so that z-score is negative 0.84. So now that I found the z-score, all I have to do is some algebra. So I'm going to say negative 0.84 equals the observation, which I don't know, this is just my z-score formula, minus my mean, which is 812, divided by my standard deviation, which is 67. So at this point, I'm just using algebra to solve for x. So I'm going to start by multiplying both sides by 67, which gives me negative 56.28. And then I'm just going to add 812 to both sides, which gives me a value of 755.72. So that tells me that adult walruses who weigh 755.72 kilograms or less are the bottom 20% of all adult female walruses in terms of weight.